Hey everybody, welcome to Lab 7, the appendicular skeleton. Today we're going to be talking about the bones that hang off of the axial skeleton. So we're talking about our pectoral girdle, which is our shoulder girdle basically. It includes the scapula, the clavicle, which I think I mentioned as part of the rib cage yesterday, which was incorrect. I was looking at that first primary rib. I don't know what I was thinking. So the scapula and the clavicle, and then that hanging off of the scapula or articulating with the scapula is the long bones of the arm, or the whole arm itself, our humerus, our radius, and our ulna, and then our hands. Okay, I almost said ankle bones. You guys, I'm so tired. The wrist bones that happen before our phalanx or our phalanges, which are the fingers, are called the carpals, and then after that are the metacarpals, and then we just end up with phalanxes or the phalanges. And each individual finger is called a phalanx. Okay, so the reason why is because that means armies, and it kind of looks like a little army of bones, I guess. I don't know. The good news is you don't have to learn every single carpal because they basically look like little pebbles all next to each other, and it's hard to identify. If you're going into more advanced anatomy classes, though, you will have to identify every carpal, just not in this class. Okay. We're going into our pectoral girdle. I'm not going to show you that. That's like, it's hanging on the front side of your body. It's what the legs attached to. So the femur, which is your thigh bone, and then following down to the scapula, which is your kneecap. Then your tibia and fibula, which their tibia is your shin bone, your fibula is right behind your shin bone, going down into your ankle bones, and your tarsals, your ankle bones, your calcareus, and your talus, and then your tarsals are the rest of those ankle bones, and then your phalanges again for your toes. Okay, so there's a lot to do in this lab, okay, because a lot of those long bones look exactly the same. Now after a while you'll get to notice that you can tell exactly which long bone is which. So today I have a deer radius, and the way I can tell it's a deer radius is because it's a long bone, so I know that narrows it down. It doesn't have one of the big bulby ends that makes it a femur or a humerus, which those have to have these big round ends so they can fit into a socket to allow us this big range of motion. Okay. The same thing with our legs. We just usually our muscles are so stiff that we can't get that much range. Okay, so it's got to either be the leg bones, or the forearm bones of this animal. And I know it is actually a radius because it's got a mostly flat top. You're going to find that in the human also. You have kind of a flat circle top. I like to think of that. Oh, the radius is something associated with the circle. So if you have a flat circle top, that's going to be the radius bone. Okay, we also know it's a radius because it has what's called another styloid process on the very end. Okay, interesting. So now I've identified this. Now I know this is a deer and not a human because what's called the radial tuberance is very, very poorly defined in this animal. It's just kind of bloop there, just a little bit, whereas in the human, it's much more obvious. Now that's what the kind of thing you need to know. If I look at a random bone, am I going to know, first of all, what bone is it, and can I identify all the features? So let's look at our lab. Let's make my face little. There we go. All right, so looking at your lab, you're going to be going through, and you're going to be learning this is the upper limbs and the pectoral girdle. Okay, so it doesn't look like a lot, but it actually it kind of does look like a lot. As you go into each part, you're going to have to learn. So these are the bones: the clavicle, the scapula, the humerus, the radius, the ulna, carpals, metacarpals, and phalanges. Each as you go underneath it. So the scapula, you have to learn these 4 things. Okay, the scapula articulates with the clavicle, so these two attach together. The clavicle is what breaks when you land on your arm because that force doesn't cause any damage, a lot of damage in the forearm, in the shoulder, in the long bone of the rest of the arm or the shoulder, because those are nice big bones. But the clavicle is pretty fragile. Okay, so that's an unfortunate side effect of being human. Okay, and so there's that. So you're going to learn each one of these little oh guys, I'm losing words today. Each of the features for each of these bones. Okay, I included a lot of figures at the end of this lab that will help you kind of just let you practice your identification, because the thing you need to do the most is practice, practice, practice. That's the best way to learn these things. And don't just practice on the same picture. Use lots of different pictures. Go on Google, find so many unlabeled, disarticulated bones or articulated bones, and just start practicing. And one way to practice will help you with these kind of things is think about these kind of questions. Okay, so if you want to list the bones of the pectoral limb, there's one in the upper arm, that's the humerus, two in the lower arm, it's your radius and your ulna, and then three types of bones in the hands, the carpals, the metacarpals, and the phalanges. Just going on. One interesting thing is if you look specifically at the radius and ulna, here we go. Here's a good picture. The ulna, and if you look at it in different pictures, you get a better idea. The ulna always looks like a little ice cream scoop, and that's your elbow. Okay, so that's what you're feeling when you feel the ball of your elbow, is that ice cream scoop. Now, we, again, as humans, aren't the most perfectly evolved species as much as we want to be. There is a nerve that comes along here that controls the arm that gets caught in that ice cream scoop. Okay, so whenever you bang your elbow and you hurt your funny bone, what you've actually done is pinch that nerve inside the ice cream scoop head of the ulna. Okay, so that's what's going on there. It's not technically called an ice cream scoop, it's just an easy way to remember it. Okay, so you're going to learn exactly what that's called. When you're labeling, remember, you only need to label the things that are in bold from the lab. So I just picked a whole bunch of different figures that I hoped would help you, because, again, on the lab practical, you don't know exactly which picture you're going to be looking at. So what I would do, again, just like in the axial skeleton, is as you're going through the lab, start making a big list of all the bones. Okay, so you're going to write down the scapula, these are the features, the humerus, these are the features. And then I would think about laying out pictures of the different long bones side by side to try and identify them. How do I know the humerus? How do I know the radius? How do I know the ulna? So you'll know the humerus because it's got this bulby head to it. So this is a humerus. It has this bulb of a head, but it's different than the femur, which is this one. This is the femur. So this is a part that fits into your hip socket. If you're, a lot of times in car accidents, when people are trying to slam on the brakes, they end up breaking their hip socket because this part of the femur just gets shoved into that hip socket. That's what happened to my dad when he was in a car accident. And he ended up now, when you say you have a false hip, usually it's they go in and they replace either part of the femur head or part of the acetabulum, which is the what the femur articulates with, okay? So again, so that's how you tell the femur from the humerus, is you just, they're originally, you can kind of think of them, they started as kind of the same bone and they've been adapted for human walking, so evolved for human walking. So this, we don't have to have as big a head in it because it doesn't have to hold up the rest of the body. Okay, so this has been reduced a bit and it gives us more motion that way. Okay, again, with all the features, why do we care about these little bumps and cleaves and blah, blah, blah? Well, that's where different bones attach, okay? Or sorry, different muscles. It could be bones, but usually it's muscles, because these are, the limb bones are skeletal muscles, hint, attached to the skeleton so that they can move them around. Okay, so our skeleton has three big functions. It protects organs. Well, this part of the skeleton doesn't, because this isn't really protecting many organs, but the skull and the rib cage definitely protect organs. Okay, they protect your brain and your heart, respectively. They provide calcium salts or inorganic salts when we need them. Cool. But they also allow for movement by attaching to skeletal muscles. So that's what a lot of these processes and features are for, is for attaching very specific muscles, which we'll learn all about after the first lab practical. Okay, so here again is our pectoral girdle. Here is the radius and ulna, the radius having the circular top if you look at it from above. I would look at it, you can find animations of all of these bones on Google and in your textbook. I definitely just practice that over and over and over. This one, again, this is the scapula. It looks like a weird pork chop. That's how I remember it. What's this weirdo? Well, it's so weird. It doesn't really fit with anything. It has a weird S kind of shape. It must be the clavicle. Okay, so that's how you remember it. And you have to remember which side is going to articulate with the sternum, which is where your ribs are. It's going to be this flat one. Which one's going to articulate with the acromion process of the I really believe it's acromion process of the scapula. It's going to be the kind of curved side. Okay, because on the back you see it's flat. All right, so again, I know this is my femur. I know if this, let's see, this is kind of a triangular shape. That's going to be your shin bone or your tibia, and behind the tibia is the fibula. So the long one that kind of tapers to an end is the fibula. Now don't get those words mixed up. It's tibia and fibula. Okay, since they're Latin words, they often end in an E instead of an S, so tibiae and fibulae. Oh, you guys. But again, you're going to remember to make sure you know the features for those bones. Here's the hand. Again, these are the carpals. You just need to know them in general as carpals. This is the metacarpals. They're the ones that are underneath your palm. okay? And then the phalanges start after that, okay? Excellent. And I put them next to the foot so you can have a comparison. We have the calcaneus and the talus, okay, here and here. We have some tarsals, and then we have metatarsals and phalanges once again. Oh, what's this bad boy? This is both the pelvic girdle, this is the pelvic girdle, and this is the sacrum, okay? So remember, this is actually part of the vertebral column. And you can tell that it's a part of the vertebral column because it kind of looks like a bunch of vertebrae that have fused together, because that's exactly what it is. And you can see where they have these foramen for nerves to come out of the spine and go into the rest of the body, or specifically, usually the legs, okay? So in this case, you want to make sure you can identify the what's called the os coxa, or the bones of the hip, versus the scapula. So I would put those two things next to each other and make sure you know, well, there's a weird flat looking thing. Here's a kind of twisty looking, flat looking thing. How can I make sure I know which one is which? Okay, so that's plenty to do in this lab. I'm going to leave you with that. There are some practice questions to kind of help you identify which bones are which, and what makes up certain parts of the different notches and etc. And again, other ways that you can kind of help yourself test your retention of these specific bones. Good luck, and I will talk to you later.